Hi, I'm going to talk about the first lab, which is charge tapes. The purpose of this lab is to determine approximately how much excess charge is on one piece of charged clear tape. Fundamental physical principle used is electrical force. This is an observed model. The system is tape B and the surrounding is tape A. The initial conditions are tape mass, tape length, tape width, and the distance between the two tapes. The assumption made is that each tape is 1 point charge, so the equation is more simple. There are two main physical ideas. First is Coulomb's law, which states that the magnitude of the attractive or repulsive electrostatic force between 2 point charges is directly proportional to the product of the magnitudes of their charges and inversely proportional to the square distance between them. The second one is gravitational force, which states that the gravitational force is directly proportional to the mass. For a brief preview of the result, the tapes will be positively charged, which results in repulsion when near each other. For a quick explanation, I've created constants and objects and set initial values. Then I created functions that calculate electric force and gravitational force. Lastly, I made sure to draw the first diagram so that it appears as shown in the picture. The errors involved here are: first, weight is an estimate; second, the separation between two tapes was not accurately measured; third, forces from the surrounding are assumed to be negligible. From now on, I will answer the questions that were on the worksheet. The net force on tape B is 0, and the vertical forces acting on tape B are gravitational force and electric force from tape A. To find the gravitational force, we must know the mass of the tape, and in order to determine the gravitational force on tape B, the length of the tape should be measured. The magnitude of the gravitational force on tape B is 0.000196 Newton, and the separation distance at which tape B begins to float was 0.0035 meter. Charge on tape B is 1.63 times 10 to the power of -9 coulomb, and the calculation was done based on the fact that the magnitude of the electric force and the gravitational force is the same. The deficit of the electrons is 1.63 times 10 to the power of -9 coulomb, which is the same as 1.021 times 10 to the power of 10 electrons. The number of atoms can be calculated by the area of tape divided by the area of one atom, which is 4.2 times 10 to the power of 16. Therefore, the ratio of electrons to atoms is 1 to 4.2 times 10 to the power of 6. The assumption made is that the tape is 1 atom thick. Thank you for listening to the presentation. This was Esther.